Okay, this is the first video on a sequence of videos about teaching statistics. A lot of you, more than likely, if you're watching this video, are preparing to teach statistics maybe for the first time, and probably preparing to teach statistics for dual credit offerings through your local high school and Shawnee State University. When we talk to high school teachers about their fears of offering dual credit courses, I guess their biggest fear was completion of the graduate level mathematics, but the other thing we heard was that people didn't really know how to teach statistics. They were fine with calculus, fine with algebra, trigonometry, but the idea of teaching statistics was kind of a daunting task. So the grant hired me to put up a sequence of videos to give you an indication of things to think about, how to prepare, so on and so forth. So guys, first of all, this is probably first going to be delivered to a group of people who know me. You either probably had me as a professor in undergrad and or graduate school, but hopefully this extends into professional development for other people as well. So guys, again, my name is Doug Darborough. I'm a professor of mathematics at Shawnee State University. I came here in 1994. I have a PhD from the University of Kentucky along with a Master's of Arts, and my bachelor's is from Morehead State University. I primarily teach statistics. Looks like I could have chosen a better picture. I don't know why, considering I'm preparing for multiple trips to Mexico, why I chose something so cold, but oh well, that's evidently a fun day, I don't know. So guys, at Shawnee, I primarily teach statistics, finite math, and the calculus sequence. First thing I want you to think about is how to prepare for teaching statistics. And first thing I would recommend that you do is take a look at what the experts do. Now, guys, in no way am I saying I'm an expert, but I have learned from the experts, and I'm going to give you some sources about where you can go to get ideas for teaching your first statistics course. Second thing, build a common theme. Even though statistics is presented in definitive components, descriptive statistics, two variable statistics, probability, and so on, you've got to build a common theme, and I'll do that throughout the training videos. Get a grasp of technology. We're going to use two in this class, or two in this illustration. I'll illustrate how we use the graphing calculator and how we use R, which is a free statistical software package. Guys, think it through. How are you going to assess your students? And finally, how are you going to assess yourself? At the end of at the end of every class, I step back and kind of give myself a grade as I will with my students. Think about how you're going to assess yourself. Recommendations. A few years ago, there was a cohort, a group of statistics professors who got together and thought, what do we want statistics education to look like in this day and time? It was funded by the American Statistical Association. There were two groups, K through 12 and Introductory College Statistics. My focus on GAZE has been through the Introductory College Statistics part for obvious reasons. Now, what I'd like for you to do is, when preparing to teach your statistics class, and I'm going to cover some of that in this initial video, but just Google GAZE and ASA, and you're going to get lots of documents. But look at the, kind of keep it simple. Look at the recommendations, and kind of build what you think is important with what they think is important, and create your own approach. Recommendation number one from GAZE is emphasize statistical literacy and statistical thinking. At the end of the day, why do students even need to take a statistics course? What's the need for the basic language and notation? And provide motivation for why graphs are appropriate in displaying your data. Recommendation number 2, guys, this is an important one. Use real data. Don't just come up with 1, 2, 7, something like that. Get some data that actually represents a measurement taken on people. In the day and time that we live in today, in the era of selfies and Twitter and living our lives on Facebook and all that stuff. Sometimes self-generated data can be really cool. So maybe go in the first day, create some cool data from your students, and when you analyze the data, you're actually going to be able to tell a story about them. And in this day and era, that may be very, very, very productive. Recommendation number 3: stress concepts, not procedures. Guys, make generating the numbers easy. Use technology, but focus on what the numbers mean in terms of telling a story. So the last bullet: decrease focus on the procedure for finding the number, increase the focus on what the number tells you in terms of understanding the measurement of whatever the phenomena may be that you're interested in learning more about. Recommendation number 4: foster active learning. This is really working nicely with the flipped learning format, in that students are going to watch the videos because, excuse me, before coming to class. So you're going to be able to use the class time to, take the information provided in the videos and do some cool things with it. And I'm going to show you some things throughout the videos that I use. Recommendation number 5: use technology to analyze data. Guys, I believe, first of all, eliminate those tables. In the back of every statistics book, you will see tables of probabilities. Eliminate those. Let's use R, let's use the calculator, Excel, StatCrunch, certain applets that are available, just doing simple searches on Google. Let's use those instead of those crazy tables that are in the back of textbooks. Recommendation number 6: think about the cycle of assessment and learning. You present material, hopefully students are learning. You give an assessment, you analyze your assessment to see if learning actually did take place. In your handbook of assessments, include different types. Activities are cool. Presentations are cool. Written reports. Critique of articles. Aside from homework, quizzes, and tests, the things that we typically use, be creative here. Think of other ways that students can analyze data, tell stories, and be graded on. Mastery learning is also a very effective technique. Some students, for one reason or the other, just learn more quickly than others. It doesn't mean the student who learned at a slower rate can't learn. It just means that they didn't learn as quickly as possibly the other students. So consider investigating mastery learning for your classes. Guys, the video is going to be in 5 components, and I'm not really sure as I post this first video exactly how many videos that you'll have. I know there will be probably 8, and I doubt you're going to sit down and watch all 8 videos at one time. More than likely what you'll do is, when it comes time to teach descriptive statistics to your students, you'll probably want to follow the link of the descriptive statistics. What I'll do there is provide a definition of descriptive statistics. We'll talk about data, variables, and we'll talk about quantitative and categorical data. We'll also look at the appropriate numbers that we would use to summarize quantitative and categorical data, as we'll look at the appropriate graphs to display categorical and quantitative data. The second component of the class, also under the descriptive statistics realm, is 2 variable statistics. If we have 2 quantitative variables, how do we describe the relationship? So that's the second component. The third component is where we actually get into looking at samples and populations. In descriptive statistics, we're primarily interested in, okay, we've collected a sample. how do we describe this particular sample? The normal distribution starts the process of being able to take the sample and generalize to a larger population. So we formalize histogram shapes and you know, bring in terminology such as percentages and proportions. Guys, the fourth part of the video sequence will be sampling distributions. I think it's the most important because it bridges descriptive statistics with inference. Without question, inference is probably the most important component, but I think the most important topic is this of sampling distributions. When I look at what people do in their introductory statistics courses, I'm always kind of shocked at how many people kind of skip over this. And I really don't know how they can ever generate or motivate inferential procedures such as confidence intervals and hypothesis testing if they don't have a pretty thorough understanding or at least framework of sampling distributions. Sampling distributions just tell you if we were able to dive into a population and take out every possible sample, how would these things behave? Where would they be centered? What would the distribution look like? How would we explain the variation? How would we explain the variability? Well, we're going to do this again as a bridge to inference. We're going to look at sampling distributions for quantitative and categorical data and get into all kinds of cool problems related to sampling distributions. Guys, the final component is inference, and there's two parts of inference that we'll present to our students: confidence intervals and hypothesis testing. Confidence intervals is just a way to estimate an unknown value from a population. We'll need to have a pretty thorough understanding of sampling variation, a margin of error. And hypothesis testing, very straightforward procedure, but a concept that students tend to struggle with. Hypothesis testing is a procedure by which we can test a claim or a status quo of a value from a population. So, guys, my goals for this video are pretty simple. First thing I want you to realize is this is my approach. Not everyone who teaches statistics teaches it like me. In fact, there's some very, very, very good statistics professors who teach things, slightly different than me. So again, keep in mind throughout these videos, this is my approach. And what I ultimately want you to be able to do is to watch the videos, take my approach, put your creative spin on things, and ultimately create your approach. Okay, but this is going to be just a illustration of the framework of preparing for and presenting and, of course, assessing an introductory statistics course. So guys, in summary, what I'll do here, I'll tell you what I've learned over the years. I've been teaching statistics now for almost 20 years at the college level. I'll tell you how I teach and what I stress. So guys, that's it. Welcome to the to the sequence. I hope I don't bore you too much. So take care.